Okay, today we're going to look at 7.1 and at least part of 7.2. So let's take a look at our notes. I have gone through and picked out all of the systems of equations where the directions indicate to solve them using substitution. So this is 1 and 3 and 6. So we're going to do those first because they are all done with the same method, substitution. So remember, substitution, you've done this before, so this is the same substitution that you've always done. To do substitution, you pick a variable to get by itself. Now, any variable will do, but my suggestion to you is pick one that's already by itself. In other words, pick one that doesn't have a number hooked to it. So in this case, I am going to pick this x right here. And I am going to get that x by itself by subtracting the 2y. So x equals 4 minus 2y. Then take that x value, the thing x equals, and plug it in for the x in your problem. Now again, kids, the directions tell me that I must use substitution. So that's the method that I am using. I got x by itself. Now I'm going to take this guy right here and plug him in right here. So my new equation will be 2 times 4 minus 2y minus y equals 3. So 2 times this minus y equals 3. Then I'll just do my distributive. 8 minus 4y minus y equals 3. 8, collect my terms. 8 minus 5y equals 3. Subtract 8. Negative 5y equals negative 5. Divide by negative 5, so y equals 1. Now, you might remember from when you did these before that that's not enough. You're not done. When you solve a system of equations, you are looking for where these two lines cross each other. So your answer is going to be a point. It's going to be an ordered pair, an x and a y, where they cross each other. So you have figured out that y is 1. So then we go back to our original problem, and anywhere up there, plug in 1 for y. You can plug it in here, you can plug it in here. Personally, I like to plug it in here, because if I plug 1 in here, I'm going to have 4 minus 2. I'm plugging in 1 for my y, so 4 minus 2 is 2. So the answer to the question, since solve the system, the answer to the question is 2 comma 1. All right, we're doing the same thing with this problem. Only the good news is, now the bad news is I know you see a square. Don't worry. The good news is y is already by itself. So we're going to take this y value right here, and we're going to plug it in right here. We know that y is x plus 1. So that top equation says x plus 1 squared equals 5. I'm taking whatever y equals and plugging it in. Now this is a FOIL, so I am going to have to multiply x plus 1 times x plus 1. I'm going to FOIL that out. First, outside, inside, last. And then I'm going to clean everything up and get it set equal to 0. So, x squared, 1, 2, 3x plus 1 equals 5. Move this 5 over. X squared plus 3x minus 4 equals 0. I'm subtracting 5 from both sides. Now, what do I do with that? That's a little quadratic. What do I do with that? Well, you can use the quadratic formula if you wish. Some of you like to use that, absolutely fine. This one also factors. It's a little quicker to factor it, but you don't have to factor it. If you want to use the quadratic formula, you absolutely can. But there are the factors. Now, what does that mean? That means that this time there are going to be 2 points because there are 2 x values. So x can be -4, these are x values, or x can be 1. So since there are 2 x values, there's going to be 2 y values. So I'm going to go back and plug in my x values one at a time, anywhere I want. It makes sense to me to plug them in right here. So y equals -4 plus 1, that will be -3, or y equals 1 plus 1, so that will be 2. Two answers. And you might be saying, Ms. Ford, why are there 2 answers? Well, remember, a squared equation is a parabola. So this is actually a parabola equation. Now, because the y is squared, you don't need to know this right now, but because the y is squared, it's sideways. This is a line, and can't a line and a parabola cross each other twice? Yep. Now, 2 lines can't. 2 lines are only going to cross once, but a line and a parabola can cross each other twice, and that's why I got 2 answers to the problem. Okay, one more with substitution. When you do substitution, get one variable by itself, and I would choose that x right there. Again, it doesn't matter. Kids, it makes no difference. Get whatever variable you want. I like to keep it easy, so I always get the one that's already kind of alone, plain x. So I'm going to add that y to the other side. So x equals 4 plus y. And then I'm going to take this right here and plug it in for my x value right here. So I have 2i minus 2 times 4 plus y equals 3. So I took my top equation, added y, that gives me x equals. I took the x equals thing and plugged it into my other equation, and now I'm going to do the distributive. What do you think? No solution. How can there be no solution? Well, the original 2 lines were parallel to each other. And if they're parallel to each other, they aren't going to cross, and therefore, they will not have a point of intersection. These are parallel lines. No solution. They are parallel lines. How do I know there's no solution? Because there is no way that -8 can equal 3. No way can that happen, ever. So, no solution. All right, now we're going to go back and do all the elimination problems. So here's problem 2. And problem 4. And in a little bit I'll erase that and put problem 5 over there. All right, so elimination, again, you learned how to do this before. Elimination is a process that will accomplish the same thing substitution does, except you do it a different way. I personally like elimination better. The idea of elimination is you eliminate a variable. So in this particular case, I will choose to multiply my second row by 3. Now, why would I choose that? Well, my top row stays the same. But if I multiply my second row, my second equation by 3, I'm going to get 15x plus 3y equal to 24 times 3, which is 72. Now you've done this enough, you know exactly why I did that. I did that so that when I add these two equations together, the y's will cancel out. In other words, a variable has been eliminated. We eliminated a variable. That's why we call it elimination. So 17x's, I'm adding, 17x's equal 85. So x equals 85 divided by 17, which is 5. Just like before, 5 isn't the answer. The answer is an ordered pair. Now we know that x is 5. So we'll go back to any equation you want. It doesn't make any difference. And you plug in 5. So I'm going to go back for x. So I'm just going to go back to the first one. 2 times 5 minus 3y equals 13. So 10 minus 3y equals 13. Negative 3y equals 3. I'm subtracting 10. So y equals negative 1. There is the solution to your equation. System of equations. All right, now I'm going to do the same thing. Now, I know these are squared, but that doesn't matter. We can still eliminate them. So if you look at that, could we do the same thing? Could we multiply the bottom one by 3 again? We absolutely could. Now, could you do other things? Yes. Yes, you can do other things. But one possible thing is to multiply the bottom equation by 3. So I have x squared minus 3y squared equals negative 11. That one didn't change. Then I have 6x squared plus 3y squared equal to 18. The biggest mistake, you all know how to do this. This is easy. It's going to be A plus for you. Biggest mistake I find is when we multiply by 3, we forget we have to multiply everything by 3. So it's the whole equation. Okay, so 7x squared equals 7. X squared equals 1. And then when I square root, I get x equal to, watch it now, plus or minus 1. Remember, when you take the square root of both sides, I don't care what kind of equation it is, when you're taking the square root of both sides, it's plus or minus. Okay, so I have two answers now, just like I did before. One of them has an x value of 1, one of them has an x value of negative 1. So then I go back anywhere you want. I don't care, it doesn't make any difference. I think I'm going to go back to the second one this time. I'm going to plug into here. There aren't any negatives to worry about. I'm just going to plug it into that one. It does not matter. Plug it in wherever you want. All right, if I put in 1 squared is 1 times 2. So that's 2 plus y squared equals 6. I'm plugging in positive 1. So y squared equals 4. What happens when I square root? I get plus or minus 2. So that's really 2 points. That's really 1 comma 2 and 1 comma negative 2. Now, I'm okay with you writing it this way. That's fine, totally fine. But I want you to realize that really represents 2 separate points. Okay, now do the same thing. but plug in -1. Come on, use your head. If you plug in -1, aren't you going to get exactly the same thing? Because -1 squared is 1 times 2. So this one is also going to be plus or minus 2, which is 2 more points. So there are 4 points of intersection here. And again, you don't need to know this, but that top one is a hyperbola. So I don't know exactly what it looks like, but rough sketch, it's a hyperbola. The second one is an ellipse. They cross in 4 places, so that's perfectly okay. You don't need to know that. You need to come up with this. Now I know somebody out there is wondering, can I write that? Plus or minus 1, plus or minus 2? You absolutely can. That represents 4 points. So if you mean literally all 4 combinations, it's perfectly okay to write it that way. All right, you don't have to write it that way. Just get the answer. Last one, substitution. Or no, we already did that one. Doing elimination. Number 5. This is number 5. Okay, we're eliminating. I don't know if you noticed this or not, but things are kind of not right in terms of lined up and all that. So I think I'm going to go ahead and move this 6y over. So my top equation looks like this. And then my bottom equation looks like this. So I'm going to add this 6y over to here so that everything is lined up. If I'm going to eliminate, I need everything to be lined up. Okay, so now I need to eliminate something. So maybe we'll multiply the top equation by -2. So all the way across, we'll have -2x, -6y, -16. And bottom equation, leave it alone. And I did that so that I would eliminate my x's. But what happened? Not only did we eliminate the x's, but we eliminated the y's, and we eliminated the numbers. So when I add, what is left on the left side of the equation? Nothing, 0. What is left on the right side of the equation? Nothing, 0. Now that is different than what happened before. I can't remember what happened before, but it was something like 3 equals 8. No, it doesn't, ever. That was no solution. What's this? This is infinitely many solutions. Please do not say all real numbers. I will mark it wrong if you say all real numbers. We are looking for where these lines intersect each other. They intersect each other in infinitely many points. So you are either going to write infinitely many solutions, or it might be easier for you to simply write, these are the same line. They are the same line. If you graphed these 2 lines, they would be right on top of each other. So where do they cross? Infinitely many points. Every point on the line is where they cross. All right, 7-1 is done. Please check Schoology and Power School to see when that homework is due. Now, we're moving on to 7-2. 7-2 is about matrices, matrix and matrices. So first we're going to get through some vocabulary, some basic matrix vocabulary, and then we're going to do some basic matrix problems. So, what is a matrix? A matrix is a rectangular array of numbers arranged, sorry about the slant here, the TV got in the way, in rows and columns. Now, you guys, I want you to write that down because I guarantee you 100% that's going to be a test question. This chapter is largely about matrices, doing lots of operations with matrices. You need to know what a matrix is. It's what the whole chapter is about. So a matrix is a rectangular array of numbers arranged in rows and columns. So if you look down at problem number 1, we have some matrices. So let me just look at that first one so that we can talk about it. Actually, let's look at B. Let's look at B. So B is 2, 0, 3, and negative 1, 1, 4. Okay, this is just our example. We're just looking at B right now. Down there, problem number 1. This is a matrix. We use capital letters to denote a matrix. So here it is. It's a rectangular arrangement of numbers in rows and columns. Okay, a rectangular array of numbers arranged in rows and columns. So here are the rows. Rows go sideways, like bleacher rows. Think of bleachers. These are the rows. Columns go up and down. Think of the White House. Columns of the White House. So rows of bleachers, columns of the White House. Okay, when we talk about the dimensions of a matrix, the dimensions of a matrix are basically the size of it. It's rows by columns. Now, this is not a times, this is by. Just like when you buy a piece of lumber and it's a 2x4, those are its dimensions. This is a rows by columns. So matrix B has 2 rows and 3 columns. So it would be considered a 2x3. His dimensions would be 2x3. Dimensions of a matrix, rows by columns. A square matrix is a matrix that has the same number of rows as columns. So a square matrix would be like matrix A in problem number 1. It has 2 rows and 2 columns. It's square. Just like if a room is 10 by 10, it's square. If a piece of paper is 12 by 12, it's square. If a matrix is 2 by 2, it's square. 3 by 3, 4 by 4. Same number of rows as columns. A rectangular array of numbers. The numbers inside the matrix, these numbers right here, are called entries or elements. You can use either word. The numbers inside a matrix are the entries or the elements. So these are the entries of matrix B. A scalar is simply any real number. So you need to know the word scalar. Those of you in physics certainly know the word scalar. A scalar is just a real number. In matrix land, we're going to think of scalars as kind of like coefficients. And then equal matrices, it's a 2-part definition. Equal matrices are a 2-part definition. The equal matrices have to have the same dimensions. And I hope that makes sense to you? Because if we have equal matrices, then they need to be the same size. So they don't have to be square, but the two that are equal will be the same size. So 2 by 5 equals 2 by 5. But more than that, not only are they the same size, but they have to have the same corresponding entries. Now, what does that mean, the same corresponding entries? It means you have the same numbers in the same spots. So in other words, if I had this matrix, 1, 2, 3, 4, and this matrix, 4, 3, 2, 1, they are not equal. Now, they're the same size, and they have the same entries. But you see why they're not equal? The entries are not in the same spots. Now you're thinking to yourself, okay, I get it, Mrs. Ford, but why in the world, why is this important? Well, if we had a situation where we had to figure out, we knew these two were equal, but we had to figure out something over here. I just made it simple, X, Y, Z, A. We could say, well, if they're equal, then X has to be 1, and Y has to be 2, and so on. We'll do something like that. So it's just important right now that you understand, if they're equal, it means this is this is this, and so on, and the matrices are exactly the same size. All right? That's our basic vocabulary. Now let's see if we can do a few problems. Here's matrix A. And here's matrix B. And the first question says, what are the dimensions of A? Remember, dimensions are rows by columns. Rows are bleachers, sideways. So how many rows does A have? 2. How many columns are up and down, like the White House? How many columns does A have? 2. A is a square matrix because he is 2 by 2. Now, what about B? Well, the dimensions of B, again, is rows by columns. How many rows does B have? 2. How many columns does B have? 3. So B is a 2 by 3. It is not square. That's fine. It's a 2 by 3. All right, so what does this mean? Well, a minute ago, I don't know if you caught it or not, but I told you that we use capital letters to name or identify our matrices. So capital A is this matrix, capital B, and so on. Notice in problem letter B, in 1B, these are lowercase letters. The lowercase letters refer to the numbers inside that matrix. So since that's an A, it means I'll be looking in matrix A. The subscript here indicates the row and the column that the number I want is in. So I want to know what number that is. Well, it's in matrix A, and it's in the second row, first column. So second row, that's this row, and first column, that's this column. So the number that is in row 2, column 1, is 3. So the answer to this question is 3. The little letters are simply asking you to find an entry in whatever matrix. So here it's a B. So I'll be looking in matrix B. The first number is always row, second number is always column. I remember Roman Catholic. That's how I remember. It's always RC, rows by columns. So first row, second column. So I gotta be in the first row and the second column. So the number that's in that position, row 1, column 2, is a 0. All right, now I'm going to matrix C. Row, column. So I'm going to matrix C, and I'm going to find the number that's in the 3rd row and the 1st column. Oh, this one got a little tricky there. There isn't one. Why isn't there one? Because matrix C does not have a 3rd row. So there is no entry that is in that position. All right, now we're going to add matrix A and matrix B. And I'm going to tell you right now, you can't do it. You can't do it. Why do you think you can't add matrix A and matrix B? Because they aren't the same size. In order to add matrices, they must be the same size. Now, Mrs. Ford did not say they have to be square or anything like that. No, that's not the case. They just have to have the same dimensions. So one of them's 3 by 4, the other one has to be 3 by 4 in order to add them. You will find there are a lot of situations that are impossible in matrix land, so don't be alarmed. We just had 2 in a row where we got no solution. That happens a lot, don't worry about it. All right, what about A and C? So now we're going to try to add A and C. Now, are they the same size? Yes, they are. So when matrices are the same size, they are addable. You can add them. So A and C. To add matrices, you add the numbers in the corresponding spots. So I'm going to add this one and this one because they're both in that spot of their respective matrices. So 1 and -1 would be 0. I put my answer in that same spot. Top left, top left, top left. Okay? Now I'm going to add top right, and put it here, top right. So 2 and 1 makes 3. 3 and 4 makes 7. And -4 and 0 makes -4. And there is the answer to the question. That's all there is to it. All right, so now I'm going to do 2A. So I'm going to take 2 times matrix A. Now, this obviously is a matrix. This is what we call a scalar. Remember I told you that we would think of it as a coefficient? It's like a coefficient, only in matrix land it's called a scalar, just a real number, 2 in this case. And we're going to take 2 times matrix A. Well, how do we do that? I mean, what's your common sense say? We're just going to multiply 2 times all of those things. So 2 times 1, 2 times 2, 2 times 3, 2 times -4. Done. That's all there is to it. It's like distributing. You're just going to take the 2 times everything inside the matrix. All right, next we have 2C minus A. So 2 times matrix C minus matrix A. Now, before I get too far into this problem, is it doable? Now, subtraction has the same rule as addition. You can only subtract if the matrices are the same size. So what do you think? Are they the same size? Yep, they are. So, first things first, let's multiply 2 times all of these. So negative 2, 2, 8, 0, and then minus this other one. We're going to subtract in the same way that we add. So entry by entry. So I will take negative 2 minus 1. 2 minus 2. 8 minus 3. And 0 minus negative 4. 0 minus negative 4. And there's your answer. Last one on this page, b minus 2a. Now wait, I'm going to save myself some writing here. B minus 2a isn't going to work. Why isn't it going to work? Because b is a 2 by 3, 2 rows and 3 columns. But A is a 2 by 2. Are they subtractable? No. So that is, can't do it. You can't add or subtract unless the matrices have the same dimensions. So the matrices must have the same dimensions in order for you to add or subtract. All right, a couple more, and then we'll be done for the day. A couple more of these problems. So let's see what's going on in problem 2. Problem 2 says we're going to multiply A times F. So AF means multiply. So we're going to multiply A times F. All right, so matrix A is 1, 2, 3, negative 4. And matrix F is negative 1, 5, 3, 0. We are going to multiply these together. All right, so step 1, we got to know the rules about multiplication. Back up a step. What are the rules for adding and subtracting? For adding and subtracting, the matrices must have the same dimensions. Multiplication is different. To multiply matrices, this is what must happen. What are the dimensions of A? 2 rows, 2 columns. So A is a 2 by 2. 2 rows, 2 columns. F is a 2 by 2. If you want to multiply, here's what has to happen. These 2 inside numbers, the columns of the first and the rows of the second, those 2 inside numbers must match if you're going to multiply. They gotta match. The outside dimensions, the ones not in the circles, a 2 and a 2, tell you how big your answer is going to be. So my answer is going to be 2 by 2. Now, before I do this problem, let's back up. If I were multiplying a 5 by 8 and an 8 by 6, that is doable, because if you want to multiply them, only thing that has to happen is these two have to match. The answer then will be a 5 by 6. So when you're multiplying, the inside dimensions have to match, and then your answer, your product, will be the size of the outside dimensions. Okay? These happen to be squares because that's the easiest. And we're starting easy because multiplication's a little bit confusing. But that's the rule. That's how we know if we can even do the problem. Okay? So this is a doable problem, and now we're going to do it. So what I would suggest you do, recognizing that my answer has to be a 2 by 2. These two right here give me my answer, has to be 2 by 2. That means I'm going to have 2 rows and 2 columns. You have to figure out the numbers that go in all of those spots. And here's how you do it. It is not easy. Oh, actually, it is easy, but it's not what you might think you do. There's a little more to it. This number right here, whatever it is, it's in the first row, first column, okay? This is not an 11, this is not a fraction. I am filling in this blank, and it is in the first row, first column. So I'm going over to my matrices, and I'm going to circle the first row and the first column. I'm going to write down the first row numbers, 1, 2. Next to those, I'm going to write down the first column numbers, -1, 3. So 1, 2, -1, 3. I'm going to multiply each pair and add them up. And that's the number that goes in this spot. So -1 plus 6 is 5. Wow. Guess what? You get to do it 3 more times. So let's come over here. Now what spot is this? This is still the first row, but now it's in the second column. So I'm still going to use my first row numbers. First row, so 1 and 2. But now I'm using my second column. So next to my first row numbers, I will write my second column numbers. I multiply each pair and add them up. Well, that one, this is a coincidence, kids. It just so happened, because of the numbers I'm using, that one also came out to be 5. That doesn't happen always. Please don't think it's a pattern. It's not. It's totally random. All right, now I'm coming down here. Now, what position is this? This is the second row, first column. So now I need the second row of my matrix. And I'm back to the first column. So write down your second row numbers. Next to them, write your first column numbers. Multiply each pair and add them up. So -3 and -12, -15. Again, these are totally random. Please don't be searching for any patterns. You're going to find one. You get what you get. And then finally, this is in the second row, second column. So I'm going to take my second row numbers, so 3, -4. And then my second column numbers, 5, 0. I'm going to multiply each pair and add them up, and I get 15. And that is the answer to the question. So the answer, these are not fractions. I don't want you to think those are fractions. I'm just trying to get you to see that you have 4 blanks to fill in. And to get each number, you take the numbers in whatever row it's in and multiply them by the numbers in whatever column it's in. Okay, we're going to do one more. We're going to do B, which is exactly what we just did, except it's in the other order. So it's F times A. Now, first of all, I'm going to check to see if it's doable. I have a 2 by 2, 2 rows, 2 columns, and a 2 by 2. That is definitely doable. And the answer will be a 2 by 2. So 2 rows, 2 columns. My answer is going to be that right there with numbers filled in. So where are the numbers coming from? Well, this position right here is first row, first column. So I'm going to take the first row times the first column. So the numbers in the first row are -1 and 5. The numbers in the first column are 1 and 3. So I'm going to multiply each pair and add them. So that first number right there is going to be -1 plus 15. That's 14. All right, now I'm going to move over here. This is the first row, second column. So I'm going to go back to my first row, -1, 5. But now I'm moving over to my second column, which is 2, -4. So I am writing down the numbers in the first column, and then I am writing down the numbers in the first row times the numbers in the second column. I'm going to multiply each pair and add them up. And that looks like -2 and -20, -22. Now I'm ready to move down here. This is the second row, first column. Rows go sideways, bleachers. Columns go up and down. We always start with rows. So now I'm in the second row. So I'm going to write down the numbers in the second row. And I'm going to times them by the numbers in the first column. So I'm going to multiply each pair and add them up. So I get 3 plus 0, so I just get 3. And then last but not least, second row, second column. So I'm taking the numbers in the second row, which are 3 and 0, and I am timesing them by the numbers in the second column, which are 2 and -4. So I'm going to multiply each pair and add them up. 6 plus 0 is 6. And there is the product. Notice, when I did A times F, I got that. But when I did F times A, I got this. They are not the same. Multiplication of matrices is not commutative, which means that order matters, and so you have to make sure that you're doing first times second, because it's rows of first and columns of second that you are multiplying. Okay, that's it. Be sure you check to see when your 7-1 homework's due. Have a great day.